You run git reset hard, or you delete a branch, or a rebase goes sideways, and your stomach drops because it really looks like the work is gone. And with almost any other program, yeah, it would be. But with Git, it's usually still sitting right there. Once you see why, you kind of stop being scared of these commands. Let's start with what Git is not doing. Think about how Word saves a file, or Photoshop, or honestly, your code editor. You open something, you change it, you hit save, and the old version just gets written over. Gone. That's how pretty much every program you use works. Git doesn't do that. Git almost never writes over anything, and that's a little strange when you think about it. If it's not editing your files when you commit, then what is it actually doing? So underneath, Git isn't really a file tracker at all. It's a database of objects, and almost everything Git stores is one of just three kinds of object. First one is a blob. A blob is one object, and it just holds the contents of a single file, only the bytes. It doesn't even know its own file name or what folder it lives in. Then there's a tree. A tree is the object that represents a folder. It connects file names to their blobs and subfolders to more trees. And the third one is a commit. The commit is what ties everything together. It points at one tree, points back at the commit before it, and adds who you are, the time, and your message. So a commit doesn't actually contain your files, it just points at them, and this is the part that matters. Once Git creates one of these objects, that object never changes. Every object gets a hash, and the clever bit is that hash isn't some random ID, it's calculated from the object's own contents. So change one character in one file, and the contents are different, which means the hash is different, which means it's just not the same object anymore. It's a brand new one. So Git couldn't edit an object in place even if it wanted to. Different contents, different object. Simple as that. The old blob, the old tree, the old commit, they're all still there, completely untouched, which kind of raises a question. If every commit points back to the one before it, you end up with this growing chain of commits. So how does Git know which one is the latest? Something has to keep its finger on the newest commit, and that something is a branch. And this is the part that surprises people. A branch is not a copy of your code. It's not a folder. It's not some duplicate of your history. A branch is a tiny file with one hash inside it. That's the whole thing. Your main branch is basically just a 40-character hash and nothing else. So when you make a new commit, Git just updates that one little pointer to aim at the new one. The chain of history behind it doesn't go anywhere. It just piles up. So if a branch is only a pointer, think for a second about what's really happening when you delete one. You delete a branch, and it feels final. But all you actually deleted was that one tiny file. Just the label. The commits it was pointing at, still in the database. Totally fine. Git never touched your history. You basically threw away a sticky note, which leads to the real question. If deleting a label doesn't delete the commits, then how does Git ever decide what's actually safe to throw away? And it comes down to one question. Really, just one. Can I still reach this object? Git starts from your branches, plus a few other pointers like tags and head, and it just follows the chain backward. Any commit it can walk to is reachable, and anything reachable is safe. That's the whole rule. Git isn't keeping track of what you deleted, it's keeping track of what you can still get to. So, now, picture the scary case. You do something reckless, a hard reset, a bad rebase, and the commit falls off of every branch. Nothing points to it anymore. Is it gone now? Not yet, because Git has quietly been keeping a journal this whole time. Every single time, the latest commit changes. Every commit, checkout, reset, rebase, Git writes down where you just were. That journal is called the reflog, so even after a reset knocks a commit off your branch, the reflog still remembers the exact hash it was sitting on. The object never left the database. You just point a branch back at it, and you're back. Most people use Git for years and never even know this thing exists. One thing worth remembering, though, the reflog lives on your machine. It never gets pushed. It's your own personal flight recorder, nobody else's. So, alright, objects survive resets. They survive deleted branches. Does that mean Git just hoards everything forever? No. Git does delete objects eventually. That's garbage collection. But the rules are strict. An object has to be unreachable, and it has to be old enough to expire under Git's retention policy. And that policy is deliberately patient. Git doesn't prune things the second they're orphaned, and reflog entries usually hang around for weeks. That grace period isn't laziness. It's the exact reason a commit you lost 5 minutes ago is almost always still recoverable. So, step back and look at the whole machine at once. Objects never change, so editing can't destroy the old version. Branches are just pointers, so moving them doesn't rearrange anything real. Reachability decides what's alive. The reflog remembers everywhere you've been, and garbage collection waits a long time before it cleans anything up. Every one of those, oh thank God, git saved me moments, the reset, the deleted branch, the rebase that went wrong. It's all the same story underneath. The objects were never gone. All that changed was a pointer. So here's what it really comes down to. Git doesn't protect your files. It protects the graph of immutable objects that represents your project's history. And that's why losing code is surprisingly difficult.